Okay. So we'll start at the top level, which is going to be that college class, and then we'll work our way down all the way to the course class. So here at the college class level, we are going to have a member variable of type division, right, for the division class. So we do have a include here, where we're including the division header file. And then we have several different functions under public here. One is a constructor, and then in terms of member variables, we have college name and address as type string, and then a division variable of the division class type. So the constructor is taking in all of those parameters here by constant reference, so the name, the address, and the division. And then we have some set and get functions for our member variables. So a function to set the college name, or set the address, or set the division. And then we have get functions for those as well, which are all const, right? Going back to our previous discussions on where we use the const function, right, with our const with our member functions. So we do that in particular with functions that we don't want to be able to change any of the member variables. And then we have a function here called print, which can be used to print out a college object, right? And that would work its way all the way down eventually to the course level. So the whole idea, right, is that the has a relationship extends all the way from the top level class in the hierarchy to the bottom level, right? So a college has a division, and by extension, it also has a department, right? And by extension, it also has a course. So in terms of the object in memory, right, it's going to have all of those things ultimately within it. So when we talk about the print function, that's going to print out, that's going to be able to print out everything, right, all the way down. And so that's what our header file looks like, right? Our college.h file. And now let's look at the implementation of the college class, or college CPP. So here we include the header file, and then we again, a lot of these functions are going to look the same in terms of the general approach here. So here we have first our college all argument constructor. And so it's similar to what we saw with the example of employee and date, where we're passing everything by constant reference, and then we're initializing all of the member variables on the member in the member initializer list, right, which we know is that line that has the colon. So just parameter variable on the inside, member variable on the outside, and we're doing all three of them here. And then we have our sort of our usual set of set functions and get functions, right? So we just have set and get for each of the member variables. So here's the one for our college name, which is a variable of type string. And then we have set address for the address, which is also type string. And then we have set division for the division object member variable. And then we have get functions as well. So get college name, get address, right, and then get division, which has a return type of division. And then here's our print function, which is also constant. And so the idea is that when we are working with a college object, we want to get everything printed out, right? Because of the fact that we know that a college has a division, which in turn has a department, which in turn has a course. And so if we call the print function over a college object, we want to print out all that information all the way from the top level down to the bottommost level in our composition hierarchy. So we print out the college name and address directly, and then we turn around and we call the print function in the division class, right, which is going to start printing out information at the division level, and we're eventually going to get all the way down to the course level. So similar again to the employee and date example, but now we have 4 levels that we have to think about here. And so in terms of code, right, that really handles everything that we need in terms of the college class. So really we just have this print function, a constructor, and then the kind of the usual set of set and get functions for each member variable. And again, we've talked about this issue, right, of overloaded assignment operator versus copy constructor. And so we see both of those kinds of things come into play here, right? Because when we look at things like what we did in the set division function, which that takes, that has a parameter that is a reference or a constant reference to a division object. And then we have the statement div equals d, where div is the member variable of type division, and then d is this division reference. That's invoking the overloaded assignment operator, because that's an assignment type operation. And then we also have things that are invoking, right, the copy constructor, such as the div d up here in the college all argument constructor. So both of those things come into play here, right? The copy constructor as well as the overloaded assignment operator. And we're using the default versions of both because none of these classes have their own version written out. And again, based on the things that we've been doing so far, right, it's been safe to use the default versions of the copy constructor and the overloaded assignment operator. But there are times where that's not going to be safe, right? So in particular, you have to think about things like pointers and things like pointer member variable that's a pointer to maybe a dynamically allocated value, such as a dynamically allocated array. Then you have to think about these things a little bit differently. But for here, we're fine to really just use the default versions of copy constructor and the overloaded assignment operator. And another more detail, and again, these are things that we'll see come up in chapter 10, right, when we talk about operator overloading. So in the default version of the assignment operator, because again, with both copy constructor and the assignment operator, in terms of your parameter, right, you're receiving an object of that class type, because in either case, you're copying the member variable fields from one object right to the other object. And so the default version of the overloaded assignment operator passes it by value, which means that that itself would lead to a call to the copy constructor, right? Meaning that when we invoke the default version of the overloaded assignment operator, that assignment operator in turn calls the copy constructor, because again, when you think about the parameters in that function call, if you're passing the object by value, as we saw before, that leads to an additional call to the copy constructor, because you create those extra objects when you make a copy. And so you can reduce that by passing it by reference, right? So if you implement your own version of the assignment operator, you can set it up to where it'll take the parameter by reference, right? And then that reduces the number of copy objects, right, that you're making along the way. But that's our college class here. And in particular, we'll look at this print function at each level and see how we're going to eventually work all the way down to the course level. So let's look now at the next level, which is the division. So a college, in this case, we would say a college has a division, but you could change this to where you can also do things like a college has several divisions with things like vectors and arrays and so forth. But at the division level here in division.h, we're including department.h, right? In other words, each level always includes, right, the next level down, its header file. And so in terms of member variables, we have two of them here for the division class. One is a division name of string type, and then one is a department object of type department, since that's the next level down. And then we have the similar kind of functions that we support here. So meaning a constructor that takes in all arguments, and then we have set and get functions for each of the two member variables, And then we have that same type of print function. So set division name, set department, which takes in a department object by constant reference, and then get division name and get department, which returns a department object, and then print, with both the get functions and the print functions being constant as usual. And then let's look at the implementation. So again, a lot of this is similar to things that we'll see in the other classes. So here we have the division constructor, takes in the two parameters, initializes them both in the member initializer list. And so we have some, as we know from previous examples, we have some calls to copy constructors, right? In both the string class and the department class that are going to take place here. And then we have our set functions, which again, we know are going to invoke the overloaded assignment operator, and the default version of that in turn also invokes the copy constructor. So we invoke in this case, the string class assignment. And then down here, we have set department, so that's going to invoke the overloaded assignment operator, and in turn copy constructor there for the department class. And then we have our print function down here, which prints out the division name directly, and then calls the department print function to start printing out the department level information. So the idea with the print function is at each level, we call the next level down its print function. So college print calls the division print, as we saw before, and then the division print function is now calling the department print function. Okay, so that's our division class. And now we'll go to the third level, which is the department. So that one includes course.h, since department has a course, and that's the bottom level would be course. And so member variables here is a department name of type string, and then a course object of type course. And then we have a constructor that takes in both of the two arguments. We have set functions for both arguments, get functions for both arguments, and then a print function. So similar idea across really all these classes in terms of what we have. And so now we'll look at department.cpp. Similar idea again, initialize everything in the member initializer list for the department constructor. So we're going to have some calls to the copy constructor. Then we have our set and get functions, which lead to some calls to the really both the overloaded assignment operator and the copy constructor. So we got our set department, set course, get course, and then our print function down here, which prints out the department name directly and then calls the course level print function to work its way down to that final level in the hierarchy. And so let's now look at the course level, okay, which is our bottom level. So here there's no, other than string, there's no other class to include since this is the bottom level. And then these are the member variables. So we have a name and a description of type string, and we have this course units of type integer. And again, we want to keep in mind that even here, we consider that still a form of composition because we still are having a member variable that is the type of another class. But in this case, it's a built-in class rather than one of our own. And then we have the same type of set of functions. So all argument constructor, and then the usual set and get functions for each member variable, and then the print function. So that would be course.h, and then we'll look at course CPP. And so we initialize everything here in the constructor and the member initializer, and then we have our set course name, get course name, set course description, and so forth. So just the usual set and get for each member variable, and then the final print function here, where we print out the course level information, which is the name, the description, and the number of units. So that's our class code. And now we can look at the application program. And we'll have several different tests here. But to start with here in the application program, we're creating essentially from the bottom up, right? So we create object at the bottom level, and then at each level, we use the object from the previous level to help create that object. So first thing here is we created the course object. So with COMSC 200, object-oriented programming C++, and then 4 for the number of units. And then when we create a department object, right, we use that course object to help us do that. So here on the second line, we create the department object where the department is computer science, and then the course is this core object that we created up here, right? We're using that to help create the department object. And then when we create the division object, similar idea, right? So the division here, we gave the name math, computer science, business, and culinary. And then we use the department object to help create that level, right? The division level. And then the final level, the top level, would be the college object, which we put Diablo Valley College, the address of the 321 Golf Club Road and all that, and then the division object for the division part. So now we have these 4 objects, and then we have several different tests here. So in particular, we first use the college function to call the print, and then there's going to be several additional little tests that we do throughout the rest of this application program where we're going to start changing things. And so there's some very important things that we have to take into account here, which we'll see as we run through this. But so the whole idea is we have these 4 different named objects, right? Core, DEP for department, div, and call. But we're doing this in terms of composition, right? So in the beginning, you know, it's fine because we use the course object to help create the department object to help create the division object, and the division object to help create the college object. But then you can think about things like, well, you know, what if we're, at some point later, we're going to change something in the course object? And then if you call.print, are you going to see that new course information reflected? Well, the answer to that question depends on what we're doing here, right? What type of relationship are we establishing between these 4 classes? So the idea is we're modeling composition. So at each level, we have a member variable that is a direct type of the other class, right? So for example, in the college class, we have a member variable of type div, right, for division. And then in the division class, we have a member variable of type department. So, but that's a separate object, right? You have, on the one hand, you have the course object, which is stored somewhere in memory, right? And we learned in the beginning of chapter 3 that when you have an object, that the fields are stored in order based on the order that you, wrote them out under your private heading. So course, for example, is stored somewhere in memory, but then the department object is stored somewhere else. But a department has a course, which means in addition to the string that it stores for the department name, that it also is storing ultimately the fields that make up a course object. But if you create all these objects and then you start changing, like we did down here with some of these tests, core.set course name to a different name, right? And then you do call.print, you're not going to see Chem 108 because it's a completely separate object, right? So we have to think of it from that frame of mind. So changing the course object at some point later is not going to affect all the other levels, right? All the other objects because they're separate, right? So if we're gonna do things like change things in the course object, then that needs to work its way up to the, the other levels in the hierarchy if we want to have it all, if we want to have the same information, right, at all levels here. So in the examples here, we start to change some of the different fields here, like changing the course name to Chem 108 and the description to Introduction to Chemistry. But we're also going to make sure that those changes work their way up the composition hierarchy. So for example, here at the department level, we changed the department name to chemistry, but then we also did, notice, department.setCourse with core. So what is that going to do? Well, that's going to update the course information in the department object, right? This in and of itself, right, those two lines would change the course object that's called core, but that's not going to affect the other objects in the hierarchy, such as department or division or call, right? Those are separate updates that we would have to make. But we are updating at each level in our hierarchy here. So when we do, again, department.setCourse, now these new changes of Chem 108 and Introduction to Chemistry, now that's going to be reflected in the department level. And it's in turn going to keep going up all the way to the top, right, if we continue with this. So here we change the division. In terms of the division object, we change the division name to this new division, Physical Sciences and Engineering. But we also do this call here, which says div.setDepartment with the department object. So at that point, right, we've already updated the department object with the new course when we did department.setCourse. So now we're taking that updated department object, right, and we're calling setDepartment, which is going to update all of that information in the division object. So now in the division object, after we do that call to setDepartment, now we're going to have the new information reflected there, right? The Chemistry 108, Introduction to Chemistry, and then department name chemistry, right? All of that has now made its way into the division object. And then the last thing here is getting it all into the top level object, which is that call object, which is why the last thing here was call and then dot set division div. And then in this case, we chose not to change things like the college name or the college address, right? So they're still the same. But you could also, if you wanted to, potentially change those as well with calls to, changing the set college name or set college address functions. But in particular here, the last thing that's happening is we're taking our newly updated division object, because after this call here, we've now updated everything in terms of division. And then the last thing is we need to get all that into the college object. So call dot set division div. So now everything, right, has made its way all the way up the hierarchy. So now in terms of the college object, all of this stuff that we set here, all that's now going to show up, right, if we do a print call with the call object. But the key thing here, is that if we didn't do this function call, right, and we didn't do this function call, we didn't do that function call, then we would only be making the changes in the one object itself, right? So for example, the course changes would only be applied to course. The department name change would only be in the department object, right? The division name change would only be in the division object. So we had to, in this case, think about making sure everything works its way up to the top level in the hierarchy. And so the idea is now if we call call.print, now we're going to see everything with the updated information. And then the last thing here is just an example of something that we can do. based on the way all this is being set up here. And so we do the call.print after updating our objects. And then the last line here says course name again. And then notice what it's doing is actually several function calls all on the same line. So call dot get division dot get department dot get course name. And we can think about why that kind of a thing is possible. Because what we're really doing here, in effect, is chaining function calls, right? Multiple function calls on the same line. But that's fine, right, given the composition relationship that exists between these four classes. So in the beginning, right, we're doing call and then dot get division. And then from there, we're calling get department, right? And then get course and so on and so forth. And so looking at this from left to right, well, if we start at the college level, we know that we can do that, right? In other words, we know that we can start off here with a call to get division because it has a member variable of type division. So since the college class, right, has a member variable of type division, it has the ability to call that level. And in turn, get division returns a division object, and then division, right, class, we know has a member variable of type department, so that can be used to call the get department function. And then a department, right, has the course member variable, which can be used to call get course, and then the course object can be used to call get course name. So because of the fact that we have this composition relationship, we're able to do this type of chaining. And we'll see this come up also because we call this also sometimes called cascaded member function calls or call chaining. But we're just able to do this because of the relationship that we've established here between these four classes. Oh, it's fine. It's fine here. I mean, the get, yeah. I mean, we'll look at this in a little bit of a different context later in chapter 9. Here we're looking at an example in terms of composition. But the idea is we're able to do this because of the composition, right? So for example, college object can call the get division because it has a division member variable. And then same thing for each of the other levels in the hierarchy. So we're calling each of those get functions. And it does return the object by value, yes. So that's another thing that we can notice here. Because if you look at the return, because remember that the whole issue of value versus reference also applies to the return type, right? So not only does it apply to the parameter list, but that same discussion also applies to return type, right? Because in general, it's possible to have a functions that would have return type department ampersand instead of department, right? And then when we talk about pointers, you can also do the same thing, in terms of pointers, right? Pointer return type or pointer parameter type. But here, right, in terms of the get functions, they do return by value, right? Meaning they return a value, since we're saying things like department rather than department ampersand and all that. But it's fine the way that we're doing it, because keep in mind that what we're chaining are we're just chaining get functions, right? We're not doing things like calling set functions in the calls. So if you're trying to chain things like set functions, then yes, you have to think about the implication there because if you're chaining set functions with cascading and then everything is in terms of value, then when you call one, set function, then you have a copy, and then you can have the issue of where you're calling a set function on a copy rather than the original object. But here, that doesn't really matter in this case because they're all just get functions in any case, and it was more about just seeing the final output there, in the sense of being able to show the correct course name. But yes, in general, we can think about those kind of issues as well. Mm-hmm. So it doesn't, that doesn't really come up so much here, but we will look at examples eventually where you can also, for example, chain calls to set functions, and then you have to think about that exact issue. And in fact, that changes things also because, if you're going to chain set functions in cascaded function calls, then you're also no longer going to have return type void, right? Because you have to think about how you're going to actually do all of that chaining, right? So we'll see that come up a little bit later in chapter 9 in terms of doing this kind of thing with set functions, and it gets to this exact issue that you mentioned in the chat about reference versus value, because at that point, if you're going to do cascaded function calls with set functions, then not only would you not be using void, right? You really would have to have a return type of the class type, and you would want to do it as either a pointer or a reference. So that way, when you call one set function and you go to the next set function call, you're still working off of the original object rather than copy objects. So that way, when you go through all of the set function calls, you're still making all of those changes to the actual original object. So we'll eventually see that come up. But for now, since we haven't talked about all that yet, for now we're just doing this only in the context of get functions. So since nothing is going to change anyways, right? It doesn't really matter in that sense whether the get functions are returning, right, a value or a reference, because in the end, we're still going to see the same course name either way. So we're going through all these function calls here, and then the final result is we eventually end with calling get course name. And so the whole idea is that even though course name, right, is not a direct member of the college class, right? So we can't just, do call.get course name. We can indirectly get there through a sequence of function calls by going through all 4 levels to eventually get down to the point where you do have an object that you can use to call get course name. So the way you want to think about this is that call, first of all, can call get division because it has a division member variable. And the result of calling get division is that you return, right, a division object. And that division object that you return can be used to call get department because division has a department member, right? And then get department returns a department object, which can be used to call get course since department has a course member variable. And then get course returns a course object, which can call get course name because that's a member function that's directly in the course class. So we just have another way of printing that out. And then that was the end of the application program. And now it is possible to, and you'll see this in really assignment 5, it is in general possible to, have member variables that are references or pointers, for example, like division star or division ampersand. But that's a different situation, right? Because if you do that, then you're just strictly referencing either through a reference variable or a pointer. you're referring to the other object as opposed to directly storing the information in the object itself, right? So the way we have it now represents kind of that true idea of composition, where we think of it as, you know, a college directly has a division as part of it, right? Part of it in memory. Whereas if we did something like division star or division ampersand, then it would simply be referring to the other, right, division object. So with composition, we do it in this way, where it's a direct, you know, it's a direct member of that other object class type. But in some cases, you might have two classes that need to work together, and you don't necessarily have you don't really have a composition relationship. And so in some cases, you might end up using things like a reference or a pointer, rather than having it be a direct member, which is something that comes up in the assignment 5 with the odometer and field gauge classes, as you'll see this week. But of course, going back to our discussions in terms of the application program, it does follow that if, you know, if we did do things like make each of the number variables a reference, then, for example, when you change things in the, going back to some of our previous discussion here, right? When you change things in say the course object, then the difference there is that when we think about the relationship between department and a course, and if we had said in the department, at the department level, that this was a reference type, right? So for example, type course ampersand, then the difference there is that it would be referencing that course object. So when you made a change in the course object, of course, that would be automatically reflected in department. But in the context of composition, we really think of it more as having that information directly in the object as opposed to referencing it indirectly and from another object. So we have them as direct member variables here rather than doing something like a reference or a pointer, which is why we also had to be careful here in the sense of making sure that everything works its way up all the way from the bottom level to the top level. So we have kind of two different major blocks here. We print out the original college object with everything that we set up here. And then we go through and we change several things. And then we print out the new college object where we're going to see all of these changes applied right when we do that, since everything did work its way up. And then the last thing here is we just printed out the course name one more time using the chaining or the cascading of the function calls, where we have multiple function calls on the same line, in this case just with multiple usages of the dot operator back to back